So guys, integration. So let's understand what is calculus first of all. Basically, those who are coming new can understand the concept from there. Calculus is a study of change. That is, you are analyzing what? The change happening in a particular situation. But how do you analyze change? Using a term known as infinitesimals. What is infinitesimals? For those who are coming new, just understand the idea is infinitesimals is a very, very small value which is neither zero but not measurable. That is, you cannot measure it using a scale or a certain device. So those are known as infinitesimals. So in limits, what we do is, in limits, we introduce this change to find the value of function. We use infinitesimals to find what? The value of function. Sometimes what happens is when we have a function and we put a certain value, we start to get absurd values. So to overcome those absurdness, sometimes what we do is we put infinitesimals to find the value of the function. That is what is a layman understanding of what limits is all about. In derivatives, on differentiation, what we are trying to find is the change happening inside the function. So using infinitesimals, we are finding the present change of a function or instantaneous change of a function. Okay, as the x values instantly change, correspondingly how the y value changes. So in geometrical sense, it is also measure of slope of the function. It is measure of what? Slope of a function. Okay, so that is what is differentiation all about. In integration, what we are going to do is we are going to add all these infinitesimal values. So if I take an integration, if I draw a graph like this, let's say this be a random graph. Okay, so this is the lower limit. Let's say this is the upper limit of the graph. So what I'm going to do is I'm going to find the area, this area. I'm interested in finding what? This particular area. So how will I find this area? See, because this is a random change happening. See here, when you see the graph, there are three things you can see here. One is this horizontal line, right? That is kind of a fixed. This vertical line is fixed. This vertical line is also fixed. So who is changing here? Your f of x function, right? Now in general curve, f of x can change according to its own behavior, right? This is the troubling part. If this was a pure rectangle, all you have to do what? Length into breadth. But can I apply length into breadth here? Because this function is changing. The problem is height, or this height is particularly changing at different points of time. So what I do is I introduce a small section, which is what? Infinitesimal. I'm assuming that this is a very, very small section. Okay, we denote this by the term dx. Okay, now my purpose is to find the area, right? So area function will be what? Integral of, who is the changing parameter here? F of x. Now f of x is varying from where to where? A to b into, who is the governing parameter which is governing my area? Dx. So this is what is integration. So dx is used to understand the change of function instantaneously. Because dx is very, very small. I'm showing this as in a diagram. In real life, dx cannot be seen also. It's so small, right? Just to give you a visualization, I'm drawing this dx. Actually, in actual case, dx does not even, can be seen also. So using this small visualization, we are actually finding the area of this function. This is what is a integration all about. Yeah. Okay. This is the layman understanding of integration. Now you might be asking, then how we are going to mathematically define integration, right? Okay. So that's where we come across a definition for this. So right now, let small f of x, let small f of x be any real valued function, be any real valued function such that write down d by dx of this f of x, d by derivative of this f of x is some capital F of x. Okay, I forgot to mention one thing. Let f of x be any real valued continuous function. Please also mention that. Okay, if it's not continuous, there is a slight problem. We can overcome that, but at least for definition's sake, stick to what? What? Let me repeat the statement. Let f of x be real valued. A term has to be introduced. What is that term? Continuous. So this is what definition. This is what idea? Derivative. Derivative of the small f of x is giving some other function known as capital F of x. Then write down. Then the antiderivative. Then the antiderivative. That is what do you mean by antiderivative? Whenever you are introducing some operator, you also try to find the reverse of that. Okay, so if I want to take the reverse of antiderivative, what I have to do? I have to take this operator on the other side. So antiderivative will be operated on what? Capital F of x. No, antiderivative is integration, I agree with that. But where is it operated on? Capital F of x. So the antiderivative of capital F of x is given by. So how do you write antiderivative? The sign is like this. The antiderivative of capital F of x will be small f of x plus a term known as c. What is c, guys? Integration constant. Or to be very specific, integration constant also write. Just don't mention constant because it's not your conventional constant term. This is arbitrary constant or integration constant. You can use either of those terms. C is what? Arbitrary constant or integration constant. Okay, but in the derivative there was no constant, right? But why did it came here? So the problem with derivative and this antiderivative issue, let me explain that. Okay, just tell me, what is derivative of 100? The value 100, what is the derivative of it? It's a constant term, so derivative will be 0. What is the derivative of 1 lakh? Again 0. So if I try to define antiderivative based on these two different values, integral of 0 will be what then? Will it be 100 or will it be 1 lakh? It will be some constant, I'm sure for that, but I don't know which constant value. Are you getting my point here? So if since I'm defining this in a general sense, if in the f of x there was an arbitrary constant or there was some constant value, so when I do the antiderivative of the answer, that is capital F of x, which constant is going to come, I'm not sure. This problem always arises in integration. So that's why we had to define something like this. And this is what is your indefinite integral. Because I have not used the limits here. I just taken it in a general sense. So understood what is the arbitrary constant? Why arbitrary constant came into picture? Okay, this is the issue with integration. Okay, guys. Now, how do you define definite integrals? So how definite integral works? The same logic, if I introduce a limit, where is from that a to b, capital F of x dx. Am I right? This is my integral. Now, if I apply this here, how does this behave? This function also must be restricted to this same domain, right? If my integral is restricted to this domain, my answer should also be restricted to the same domain. So, how do I represent that is, I write from a to what? B. Am I right? Now, if I try to put the value, so how to apply the limits here? If you see the previous diagram, in the previous diagram, the function is varying from where to where? A to B. Same values I have taken here, right? So if I took f of b, so if I want to find this length of the function, how will the function length be? F of b value minus f of a value. So this is how your upper limit minus lower limit comes into picture. You got the idea? So if I'm integrating capital F of x from a to b, the same logic must be applied to the answer also, right? So since f of x is varying between a to b, the length term, it's not ideal length, but if I'm assuming this as a length term, it will be what? F of b minus f of a. The same logic I'm applying here. So if I do that, what will happen? F of b plus c minus what? F of a plus c. Am I right? If I open the bracket, what will happen to the c value? C value gets cancelled out. So the only remaining term is what? This is what is taught in your textbooks directly. They say that don't consider the C. The reason why they are not considered is they are cancelling out. But the idea? So this is what is definite integral. Now in GATE examination, most of the problems are related to definite integration. Very rarely indefinite integrals are asked. The reason why? Now, this definition is very easy compared to other definitions, right? Limit definitions and derivative definitions, if we compare it, this definition was quite easy to develop. Whenever the definition is easy, always remember in maths, the problem doing will be very difficult. This kind of a definition, I call this as comparative definitions. What definitions? That is, this comparison exists, then I can write this. The problem is, before solving the problem, I don't know this comparison. And that's the challenge. If this comparison is already known to you, then you can do the reverse process. That's quite easy. But already you don't know the first idea. How can you directly compare it? That's where you have to jump to what? The trial and error method. And that's the reason why most of the students feel that integration is difficult compared to what? Your derivatives. In derivative, there was no comparison. It was just, you have to find the slope of an idea, right? And you develop the formulas based on that, and then you accordingly apply to the rules. But here, we are always going to, that's the reason why there is no proof for integral sin x dx. Even in your NCERT books, even not in any other books also, there is no proof for integral sin x dx. The only proof that you can say is, if derivative of cos x is minus sin x, then integral of sin x is minus cos x. It's a comparative proof. Because the definition is comparative. So the formulas are also what? Comparative. Whereas for sin x, derivative of sin x, there is actually a proof for that. In your NCERT books, it is given there in a detailed manner. I'm not discussing that right now here. Okay, but there is no proof for integral. The reason is the definition. Understand the problems with integration? Understood the problems with arbitrary constants? At least this basic idea is clear. Okay. Now let's do some basic problems on this. Before jumping into the problems, let's discuss some properties of this thing, definite integration. Definite integration properties. These properties are going to help us a lot. Okay, so how are the properties developed? First thing, let's say there is a function like a to b f of x dx. Okay. Now in integration, there's a famous idea known as substitution method. Have you heard about that? That is, whenever the function is very complicated, you replace that function by some other variable or some other function, and then you solve it out. The first property says that irrespective of substitution, your answer is always going to be same. Irrespective of the substitution, your answer is always going to remain the same. Okay. So integral f of x, a to b f of x dx is same as what? Integral a to b f of y dy. Here, although I have just taken x equal to y substitution, but in real life, it can be other complex functions also. Let's say if I am substituting x is equal to y is equal to e raised to x. Okay, so accordingly, then I have to modify this dx term in terms of that is e raised to x dx in terms of dy, and then accordingly I have to do it. Okay, I will show you how to manage the substitutions. Okay, so is this clear? The substitution does not change the answer of the integration. Next, integral a to b f of x dx is negative of b to a f of x dx. That is, if you change the order of the limits, your answer becomes negative. Now, when we see this negative term, sometimes we get a confusion. How can area be negative, right? In integration idea, if your area is, let's say, lying below the x-axis, that integration value will be negative. What happened? If you're in your integration, when you do the integration, if your area is lying what? Below x-axis, the answer sometimes may come as what? Negative. So negative area is not a challenging thing. The only term that is happening there is the area is what? Below the x-axis. That's the only thing that should come in your mind. Okay, area can never be technically negative. It's the positioning of the area. Okay, so in integration, the way it was defined, the area above x-axis was treated as positive, and the area below x-axis is treated as what? So that's why this can become like this also. Okay, now next thing, minus a to a f of x dx. Let's say I am integrating like this, minus a to plus a f of x dx. Now there are two parts to this answer. Depends on how the function is behaving. So how it behaves is, the answer is 0 if function is what? Odd. How do you define an odd function? What is an odd function? F of x equal to, am I right? The answer can be 2 times of 0 to a if f of x is what? Even. So what is the logic for even? That is f of minus x and f of x are equal to each other, right? Is this clear? This is the idea for even and odd function. So there are some certain things that should happen. What are the things that should happen? First of all, the limit should be what? Same negative value to same positive value. That is like minus 3 to plus 3 or minus pi to plus pi, something like that. Okay. Then second thing should happen is, you should find the nature of the function, whether it is odd or even. If it's neither odd nor even, then you cannot do anything with that. Okay, then you have to do the normal integration, but it's odd or even. If any one of the case satisfies, then accordingly apply the criteria. Okay, next. Now, one more property which is very useful, especially in trigonometric functions, is this. 0 to a f of x dx can also be written as 0 to a f of a minus x into dx. This is a very useful property. Now, generalization of this property goes like this. If I am taking from a to b, same property but generalized here. Same a to b, but how should I write inside the function? Minus x into dx. Here also same thing is happening, a plus 0. Is there any point in writing a plus 0? That's why it is just written as a. Okay. This is very useful in when you are dealing in which functions? Periodic functions, especially sine, cos, other functions, like there are other different types of periodic functions also. So in those cases, this property is very useful. Are you getting my point here? No ideas, no issues, right? So these are the properties mainly. Just hang on. Then there is one more property. Again, this is also conditional property. It goes something like this. Let's say I have a condition from 0 to 2a f of x dx. Okay, now how this condition works? It is 2 times of 0 to a f of x dx if f of 2a minus x equal to f of x. The same function, integration will be 0 if f of 2a minus x equal to negative of f of x. Okay. So I'm integrating from 2a to 0 to 2a f of x dx. Now, where is this again used? For trigonometric functions mainly. Where this function or property is mainly used is trigonometric functions. So sometimes what happens is, let's say your limit is from 0 to 4 pi. Okay. But we have some shortcut formulas developed for sine and cos. So in that case, the formula is actually derived from 0 to pi by 2. So for 0 to pi by 2, I have to convert this into half, half, and other half, right? So that scenario, you always do this property. So this is where we actually one by one start to decrease the limits. We can further decrease the limit based on the criteria here. I'll show you one example. I will show you how to handle this. Okay. So understood this condition, no issues with this. So these are the main properties. There are a lot more than this, but these are the main properties that we focus. Now I'm going to give you a shortcut formula. Okay. This is mainly for sin x, cos x, and then combination of sin x and cos x. This is regularly asked, so that's why I'm covering it. So 0 to pi by 2 sine to the power n x dx. Sine to the power what? Sin x to the power of what? N into dx. This is the same formula exists even for cos also. 0 to pi by 2 cos to the power of n x dx. The formula is same for both of them. So how to approach the formula? N minus 1, n minus 3, n minus 5. This subtraction must be done up to 2 or 1. When you reach 2 or 1 value, you should stop there. So how to subtract? The power, whatever power is there, subtract that by 1. Next subtraction is by 3. That is odd number subtractions. Next is by 5. The other if next term will come n minus what? 7. Like this it will go on. Up to where? I get value of what? 2 or 1. Divided by n. Here if I am subtracting with odd, here I am going to subtract with even numbers. Again, up to where should I go? Same value, 2 or 1. Into a term known as k. Into a term known as what? K. Now what is k? K is 1 if n is odd. If the power is odd, the value of k is what? 1. Value of k is pi by 2 if n is even. Let me give an example for this. Okay. Let's say I'm integrating 0 to pi. So I'm doing going to do two things together. Okay. So I'm integrating what? Cos 0 to pi cos raised to 7x dx. Okay. Now where is my formula? Formula is from which? 0 to pi by 2. So again I have to do what? I have to take the half of the limits. My limit actually is from 0 to pi. So I have to take what? Half of the limit. So for halving the limit, what is the property? If you want, whenever you want to make the limit by half, the property that is always assigned is this. Right? What does it say? 0 to 2a. 0 to 2a means in this case, what is the 2a value? Pi. Okay. So that property is what? F of 2a minus x or f of 2a minus x. What is that we need to know, right? So let's work it out. So first let's define what is cos pi minus x. Guys, tell me what is cos pi minus x? Cos pi minus x. You remember that idea, right? All silver teacups. I don't need to explain that, right? So pi minus x is in which quadrant? Second quadrant. Second quadrant, who is positive? Sine and cosines. So sorry, cosec. Cosine, cosec. Sine and what? cosec are positive, right? So in that scenario, now if it is pi, cos will remain cos itself. If it's pi or 2 pi or 3 pi, that is integral multiple of pi, the cos function will remain as a cos function itself. So cos x, all silver teacups just denote the sign of it. So what is the sign of the function? Minus. So which property will I apply? Which property will I apply here? First one or second one? Now this is where you have to be careful. Okay, should I go for first one or should I go for second one? Also understand the power of it. Here by the power is what? 7. So minus cos x to the power of 7. If it's an even number, actually it would have been first property. I'll show you, don't worry. So this is what? Minus cos x to the power of 7. Negative of negative's power to the negative's value to the odd power is what? Negative itself. So it is technically. So since this is negative of f of x, according to the property, the answer of this is what? Answer of this is what? 0. Understood? Now let's do another function. 0 to pi itself. Let us take sine 8 raised to x dx. Okay. Again, I have to half the function, right? Half the this thing. Limits to apply my shortcut. So again, let's see the same thing. Sine raised to 8 x. Sorry. Pi minus x, right? Is what? Sine pi. Let's forget the 8 values. Let's discuss the sine pi minus x. What is sine pi minus x? Sine pi minus x is what? Plus sine x, na? Sine x will remain as sine x. Sine pi minus x will remain as sine x. Then the sign of this, that is positive or negative, how will you determine? Second quadrant. We already discussed that, right? Pi minus x is which quadrant? Second quadrant. So it will be sine x to the power of, again, 8. So that is technically sine x raised to 8. Okay. Now, so this is actually the same original function. So according to the rule, what will happen? 0 to pi sine 8 raised to x dx will become what? 2 times of 0 to half of the pi. What is half of the pi? Pi by 2 into sine 8 raised to x dx. Right? Now I have to apply my shortcut here. Now this becomes my standard shortcut formula. Right? Here the power of sine is what? 8. So what does the property say? 2 into. Now the power 8. So subtract 8 by minus 1, 8 by minus 3, 8 by minus 5, and then 8 by what? Minus 7. Stop here. Why? What did I say? Whenever you're taking the difference with odd numbers, you should stop when you reach which value? 2 or 1. This is 1 na? So stop there. Because after that, if you go na, you will go into negative domain. So whenever you reach a subtraction up to either 2 or 1, you should stop there. Similarly, in the denominator, let's do the same thing. 8. 8 minus 2. Then what? 8 minus 4. 8 minus 6. Stop. Why? What is 8 minus 6? Stop there. Don't go further. Into then there is a k value. What is the k value going to be? K value is decided by what? The power of function. What is the power of function here? 8. So that is an even value. So if it's an even value, what did I say regarding the k value? Pi by 2. So into what? I don't have space here. Now you have to simplify this. So let me go to the next page. Or let me do it here itself. Here, let me do it separately. So this 2 and pi by 2's 2's get cancelled out, right? So pi remains. Next, what are the 7 divided by 8 into 6 into 4 into 3 ones are 3 twos. Anything else? No. So final answer is 35 pi divided by 8 into 16, 128. Yeah. Oh. So it's 35 pi divided by 128. Understood how to tackle these functions? It's quite easy, right? But if you go by your conventional indefinite idea, then that's very difficult, because in your standard formula for integration, you have sin x and cos x only for power of one formula, right? So if there is a power in sin x or cos x, you have to reduce the power to 1. So how will you convert the power to 1? How to convert power formulas into power of 1? In trigonometric functions, there is a famous this thing. What is that? Property, or famous property like this. Have you seen this? You know this, right? So using this property, you will have to convert into lower powers. But the problem is, I started with which power? Power of 8. So how many times should I do? It's a very challenging problem, right? That is, you will have to write sin square x to the power of 4, and then apply the condition here, and then take the fourth power of that. Wherever there is higher power, again do the same condition. The problem is, you'll get the answer, you'll not get the answer in 2 minutes. You'll spend a lot of time answering this. So that's why, if it's a definite integration in which the limit is from where? 0 to pi by 2, apply the shortcut. If the answer is, if the limit is not from 0 to pi by 2, with some multiple of pi by 2, then use the property, that is 0 to 2a property, and reduce it to 0 to pi by 2. And one more benefit with that property is, if it is coming as a negative function, the answer is already 0. So you will quickly get the answer. You won't waste a lot of time inside that. So understood how to tackle such functions? How to use as property? Okay. Let's do one thing. Let's start with some problems. And then I will, one by one, I will teach you the applications of integrations also. There are some applications you need to learn also. These are all double integrals. Forget the double integrals. Yeah. Let's do this problem. This is an application problem. Yeah, the volume generated by revolving the area bounded by the parabola right now. The volume generated, this question number 6. Okay. Now write down the application term also. This is doing process integration, but there is something extra you need to put in integration. There's a formula for that. Okay. Finish writing this. Can I start with the problem, because I cannot do it here. You can see now. You can read the questions in the back. Do I need to magnify? Oh, okay. Okay. So what is the question? Question number 6 or 7? Yeah. Okay. Yeah. Let's say we have a function something like this. Let's understand the concept first and then let's go to the problems. Okay. Let's say this is some axis and you have a function, random function, something like this. This be any function which is existing in the limits what? A, B. Now, what is the concept of revolution? So how I'm going to revolve it, please understand that. I am going to revolve it perpendicular to the plane like this. That is fixing this axis. I'm going to revolve what? This x-axis. So this is how the revolution is. So when I revolve it, what will happen? The same function will sometime come here also like this. Right? So there are two things that can happen in a revolution. If I revolve just the curve, what I'm going to get is a surface area. What I'm going to get is what? Surface area. But if I revolve this shaded region, what will happen now? That is, just take your books. Just imagine like this. This is your books. This binding of the book. This binding of the book is your axis. Okay. Now this page is the area. If I rotate this entire page, what I'm going to generate? Since this page is a rectangle, and I'm fixing about this page is fixed at the binding, right? So if I rotate this, what I'm going to generate is cylinder. Right? I'm going to generate a solid cylinder. So if I'm generating a solid cylinder, what I'm going to get is a volume. So there are two ways in which this question can be approached. Only one way is asked. I will discuss both of them together. Okay, let's start with the first surface. Okay, right now. Right now, the surface generated by revolving a curve. The surface generated by revolving a curve about x-axis S is equals to 2 pi integration from A to B square root of bracket what? 1 plus f dash of x. What is f dash of x? The derivative of f of x. Okay. So 1 plus f dash of x into what? Dx. So this is the surface generated. Now, next thing, the volume generated right now. So this is surface generated. Now let's go for the next thing, volume generated. Write down the volume generated due to revolution of a curve. Volume generated due to revolution of a curve about x-axis. Pi times of integral a to b f of x the whole square into what? Dx. Now guys, which question is asked for us in question number 6? So which formula should apply? Second one. So let's take the second formula. Okay, tell me. Where is x value varying from? In the question, by reading the question, let me go to the question. The value of x is the volume generated revolving in area bounded by a parabola y square is equal to 8x and the line x is equal to 2 about y axis. Oh, this question is slightly tedious also. Let me explain this. Why this is tedious? I am not revolving about what? X-axis. This is revolving about x-axis. So I have to change the formula into revolving about what? Y-axis. Right? Okay. So let's quickly draw the function to understand this. So y square is equals to 8x. So how does the parabola looks like? This is how the parabola looks like. Y square is equal to 8x, parabola will look something like this. Where I'm varying from x is equals to 0 to x is equals to 2 line. So what is x is equal to 2 line? So tell me which shaded region I'm rotating. The area inside this. But how am I rotating? About the y-axis. How am I rotating? About the y-axis. So the same formula can be derived. How to do the derive is, I took y is equal to f of x function. That's why I was rotating about x-axis. So now I have to redefine the function as x equal to f of y. How to redefine? X equal to f of y. So I will tell you the first formula. Formula is pi integral whatever a to b f of y the whole square into ty. Right? So what is this function in terms of x? If it's y is equal to 8x, then what is this function? X is equals to y square divided by 8. Sorry, my mistake. 8. X is equal to y square divided by 8. What is x is equal to 2 line? That is the limit. That is the limit of this function, right? So how will I define? Pi is equals to integral. Now where is the integral from? Now I took the integral in terms of x-axis. So what is the integral in terms of y-axis? How would you define that? If I put x is equal to 2 function, what is the point here? Please tell me the point here. If I put x is equal to 2, what is the value of y? 8 into 2, 16. Y square is 16. So what is y? 4. So it's 2 comma 4. What is the point here? 2 comma. So the limit is from where? In terms of y. Normally you used to take limit in terms of x. So instead of take the limit in terms of y. Right? Okay. Now, generally you just take the function whatever function is there in terms of y and directly you integrate. But the problem here is this function entirely I'm not taking. I need only how much shaded region? This much shaded region. So how to define this shaded region is, who is the outermost function? Who is the outermost function in terms of y? X is equal to 2, na? Right? Who is the outermost function in terms of y? X is equal to 2. And here the x's value is what? Y square by 8. So take the function as 2 minus. Now this is the critical part here. Why did I take 2 minus y square by 8? Because I don't want the entire parabola. They are saying that I need only the area between y square is equal to 8x and x equal to 2. So how to do that is, see, instead of thinking in x-axis, think in terms of y-axis. So in y-axis, if I see who is the outermost function, this function, minus whatever is the inside function. Who is the inside function? This. So how will the shape look like? Okay, have you seen cake, right? Round cake. Do one thing. Don't do this experiment. It will be very costly. Take the cake, punch in the center of the cake. Take the cake, punch in the center of the cake. So what will happen? You will have a outside there will be a disc, but inside there will be a gap like thing, right? That's how the shape will look like. Just imagine a cake which is cylindrical but very small height and punch in the center. So what will happen? Cake in the center will get squeezed, right? So the outside will remain as it is. So that's how the figure is looking like if I rotate it. Got the idea? So how we modified, understood? So always remember, your direct application formula will be very rare. Sometimes you'll have to modify the formula according to situations. Now the remaining portion is very easy. All you have to do is integrate with respect to, take the square of this, integrate it with respect to. Now do the integration, please. Again, you can apply this thing. Since this is from -4 to +4, you can apply the odd even function idea. Is it an even function or odd function? Because if I introduce -y, I'm getting the same function, right? So I can write this as 2 times of 0 to 4, 2 minus y square by 8 into what? Now quickly do the integration. 2 pi into, what is the integration of 2y, right? Minus y square by 8 integration is what? Whole square. Yeah. So let's first of all do square. I forgot that. Sorry. Let's do the square and then do the integration. So 0 to 4. Let's take the square of this. 4 minus 2 into 2, 4 into y square by 8. What is that? Plus y raised to 4 by 64. Limit into dy. Okay, whenever you see such functions, whether it's square, you have to take the square and then do the integration, right? And this is an algebraic function in the inside. So take the square and then do the integration. Okay. So v is equals to 2 pi into 0 to 4. Okay, let me quickly do that. What is the integration of 4? 4y. Right? We are doing the integration in terms of what? Y. So 4y. Next. What happened? Next is what? Y square by 4. What is the integration of that? Y square integration is y square y cube by, where is that? 4 into doing silly mistakes, man. Okay, y square integration is y cube by 3. So 3 into 2 is what? What is 3 into 2? 6. Y cube by 6 plus. Next, y raised to 4. Forget the 64. Just think about y raised to 4. What is the integration of y raised to 4? Y raised to 5 divided by 5. So I have to multiply 64 with 5. What is 64 multiplied by 5? 320. Yeah, correct. Okay. So 64 multiplied by 5 is 320. So y raised to 5 divided by 320. And the limit is from where? 0 to 4. Then do the integration finally. That is, limits, apply the limits. So 4 into 4, what is that? 16. Minus 4 cube, what is 4 cube? 64 divided by 6. Plus 4 raised to 5, what is that? That is technically 2 raised to 10. 1024. 2 raised to 10 is the famous value, 1024. If you remember the bits idea. Now just simplify whatever this value is. This can be written as 32 divided by 3. This can be taken as what? 64. Is then 32 5 16 by 5, right? Then just simplify the sums. So 2 pi into 16 into 5 into 3 is what? 15. Now 16 into 15 is what, guys? 240. Minus 32 into 5. 32 into 5 is 160. Plus 16 into 3. 48. Divided by what? Okay, 240 minus 160. What is the answer? 80. 80 plus 48. 128. 128 into 2. 256. So answer is 256 pi divided by 15. Two balance somewhere there is two balance. Two missing. That's wrong. Got it? Okay. Understood how to handle volume? Okay. Now let's go for next problem. Yeah, can you no, can you do this question number 10? Write down the question, please. Question number 10. You have to integrate y from 1 to x square cos t dt, and then you have to find dy by dt. Oh, sorry, dy by dx. Now, guys, actually, there is a rule for this. Now, there is conventional way. What is the conventional way? You first integrate from y, whatever this function is given there. Let me show you the conventional way, and then I will go to give you the shortcut also. Okay, what is the function? Y is what? Integration from 1 to x square cos t dt. Okay, right. What is the integration of cos t dt? So, guys, I forgot to mention one thing. Approach towards integration, right? How to approach integration is trial and error. Like limits, I also always give you approach towards what? Integration. So, approach towards an integration problem. Please note that down. Let me dictate that. Approach to an integration problem. In the earlier itself, I should have mentioned that. I forgot that. Approach to an integration problem. Okay. First step should be standard formulas. First step should be standard formula. Now, sometimes standard formula directly is applicable. Sometimes you have to modify the standard formula. So, write down in bracket directly or indirectly. So, whatever function is given to you, check whether you can convert into standard form. Check whether the function can be converted into what? The standard form. Okay, if that is not possible, the next idea is substitution method. That is, replace the troubling function and check whether it is solvable. Substitution method. Okay. So if substitution method also is not working, third idea is, now this is particularly related to algebraic functions. Okay. If denominator is an algebraic functions, try partial fractions. If denominator is an algebraic function, purely an algebraic function, try what? Partial fractions. That is, by partial fractions, we can split up the functions, right? Okay. Now, if that is also failing, let's go for the fourth idea. Now, as I said earlier, most of the problems in gate examination are which type of problems? Definite integration. So, apply the properties of definite integration. Apply the properties of definite integration. So in definite integration, if I discuss the properties, only one property was regarding function. Rest of the properties were regarding what? Limits. Rest of all the properties, if you can see the properties, all were changing the limits. Right? Only the first property was discussing regarding function. In first property, there was no change of limit, there was change of function there. In all the other properties, we are changing the limits. So always see in a problem, always see in a gate question, is function the issue or limits is the issue? Accordingly applied. Are you getting my point here? Okay. Now, if this 4 method fails, there is a 5th method. Product rule of integration. 5th method is what? Product rule of integration. So always remember, product rule of integration should never be your first preferred idea, because it's a very, very tiresome method. It's a very challenging method. So I never prefer it as a first method. Now, for a +1, +2 student, that is 12th standard student, he will stop this year. But we are BTech students, right? So we'll have one more method. So there is 1/6 method available. And this has come in GATE exam. I will show you the questions regarding that. Check whether Laplace transform or normal distributions are applicable. Check whether Laplace transform or normal distributions are applicable. Okay. There are some problems which can be solved with Laplace transform, integration problems. And there are some integration problems which have been solved with what? Normal distribution problems. Okay. So these are the 6 approaches that we have. So try one by one, you'll get it. Now the last step has, there have been only 4 or 5 problems entire history of GATE exam. But it has been asked. Okay. So understood the process here? Now, for this particular problem, what is the step that I'm going to take? First step is sufficient. Now, cos t is a direct standard formula. What is integral of cos t? Right? Apply the limits. Let's take the minus outside. Sin t. If I replace t by x square, what I'm going to get? Minus. Is it from 1 to? Okay, give it like that. If I introduce a minus sign inside, what I'm going to get? Sin 1 minus sin of what? Okay. So what I'm going to get is sin x square minus sin 1. Am I right? Sin x, yeah, correct. So guys, let's understand the scenario here. Now all you have to do is what? Take derivative of this. Our question is asked dy dx. Na? What is derivative of this function? What is now how to handle derivative, right? So you wrote product rule, right? So product rule is what? Outside function is what first? Sine. This is sin x square, not sin square x. Sin x square means outside function is sine. So derivative of sine is what? Cos x square into inside derivative of x square is what? 2x. And this is the answer. Now you may feel that this is the easiest method. And actually this is the easiest method. But sometimes the function can be complicated. So for that, we have developed a special rule known as Leibniz rule. Write down. Leibniz rule. D by dx of u of x to v of x f of t dt is what? F of v of x into d by dx of v of x minus f of u of x into d by dx of u of x. Now this question is actually that case. Let me show you why. What are the requirement? Dy by dx. So technically it was d by dx of what was y function given there? Integral from 1 to x square cos t dt, right? If you remember this rule in one single step, you can answer this question. What do the rules say? If we have derivative and integration together, that is outside derivative, inside there is an integration. If there is derivation integration together, you don't have to integrate it actually. All you have to do is whatever inside function is there, because derivative and integral together actually cancels out, na? Right? They must cancel out together. So whatever inside function is, replace that by the upper function. So cos t, if I replace by x square, what is that going to be? Cos of x square. Not only that, you also have to take the derivative of the upper function. That is the second part. So what is derivative of x square? 2x minus, since it's a whatever inside function is there, replace that t by the lower limit. What is called lower limit? So cos 1 into what is derivative of 1? So what is the answer? That's what we get in the earlier problems, right? This is Leibniz rule. So what is Leibniz rule? When there is a derivative and integral together, and the integral is coming with what? Some limits. So I showed you the conventional way, I showed you a special way. Now this question has been asked 3 or 4 times with different functions, obviously. Now where this rule becomes beneficial is if the inside function is quite complicated, where your conventional ways of integration are becoming very, very difficult. That's when this rule becomes very easy. Okay, because we are not doing integration, we are neither doing any weird steps also. All we are doing is whatever inside function is there, we are substituting by the limits, and the limits derivative I'm taking. Derivative is an easy process, right? That's what the benefit of this rule. Although when you see the rule, you may fear that this is very weird. It's not that weird. Is this okay? Understood? Let's go for next. Okay. Now, area bounded by the parabola, that is actually double integration. Okay, that I will show you later on. Not here. Area bounded by the curve. Okay, can you do this question number 25 by the same Leibniz principle? Let me maximize it. Zoom in. Question number 25. Again, this is derivative, right? D by dx of this function I have to do. Yes. Please, others also finish it. The green color bottle. Yeah. That bottle is hers now. Any problem? Are you getting 2x square? Quite easy, na? So Leibniz rule is quite easy to do. Okay, next. Just do this. Question 46. 46 and 47, both. Forty-six and 47, both. Forty-six is very easy. See, guys, whenever you see minus pi by 2 to plus pi by 2, try to apply even and odd functions idea. So tell me, is it an even function or an odd function? Odd function, right? If I replace x by minus x, what will happen to sine minus 2x? Minus sine 2x. What will happen to cos minus x? It will be cos x. So numerator is negative, denominator is the same function. 1 plus cos x is 1 plus cos x is. Okay. So the function is remaining same. Which denominator part? Numerator part is negative. Negative by positive is technically which function? Negative function. Since it's a negative function, what is the answer of this? Do you need to even pick the pen? Okay. So these are the lottery problems. Very rarely you get it. Every year you will get 1 or 2 questions from maths like that. Okay. Which will be actually you will be able to answer orally. But the problem is it's from which chapter I don't know. That I can never predict. If I'm designing the paper, obviously I can say it. Otherwise, I cannot say it. I'm not the one who is designing the paper. Okay. And they don't give it externally. Gate paper is very rigidly designed. They have their own internal special committees. Whereas for your placement exams and other exams, they are revived externally. That is, their papers are set externally. Okay, so understood this. Now, what about question 47? X log x. Now, guys, x is not the problem here. Who is the problem? Log x doesn't have an integration standard formula. Integral of 1 by x is log x. That's for sure. But there is no formula for integration of log x. So whenever you hear log x, there are 2 things that can happen. either substitution is going to work out or product rule. Okay. So there are two things that can happen in such functions. Either substitution is going to help you or product rule. Okay. Now, why I went for product rule and substitution? Because in my approach, if you understand, standard form is not substitute, then I have standard form is not applicable. I have to go for the second step, which is substitution. Now, when is substitution applicable? If so, who is the problem and how to do substitution is, who is the problematic function? Log x. If I put log x is equal to t, what will happen? If I put log x is equals to the variable t, so I have to replace the variable dt, dx also. So if I take differential, what is the differential? 1 by x into dx. Differentiation and differential is a different story. Differential means whatever function is there, you take the differentiation of that, and after that, whatever variable is there, take the dx of that. So what is the differentiation of the differential of t? What is differentiation of t? 1. If I derivative with respect to t, then write 1 into dt. Now the trouble is, do I have dx by x in the function? Now some might may say that yeah, we can generate it by taking multiplying by x and x square. Okay, then what is the trouble here is, let me show you why substitution sometimes may create headaches on its own also. So if I do like this, or I can write like this, dx is equals to what? X dt. What is x actually? If log x is this, then x is what? E raised to t. So I can write it as e raised to t into dt. Now, what is the integration now? X will be replaced by what? E power t. Log x will be replaced by what? T into e power t dt. Okay, so this function is coming as what? 0 to 1 t into e raised to. You started with a complicated function, you created another complicated function. So it's a useless exercise. Okay, this is an indication that your substitution method is failing. Actually, this can be worked out further, but don't try to work it out. Now, there may be some doubt here. In your conventional 11th and 12th, the faculty used to say that whenever you are doing substitution, you have to also change the limits. But I have not changed my limits, right? I don't change the limits. That's my way of doing it. The reason is sometimes while applying the limits, we may create other problems also. So I do the integration in the same limits, but before substituting the limits, I convert back into the original variable. Before substituting the limits, I resubstitute back into what? The original variable. That's why whatever my mistake is always contained inside the function. Sometimes what happens is, while this changing the limits now, you might take a different wrong value. That happens regularly. So to overcome that mistake, what I do is I do like this. Before resubstituting, what I do is I don't substitute in t, I substitute back into the variable x. So what is the substitution for t? Log x. So wherever there is t, I will replace that by what? Log x. Okay. So we realize one thing, that substitution method is failing. So now we have to go for what? Third idea is obviously not successful because there is no algebraic function in the denominator. There is no denominator here, right? Denominator is technically 1. So again, that is not successful. Properties. Why I am neglecting the properties is, see, there is only one function changing property, which was substitution. We checked out substitution and we failed with that. Other properties, what did I say? They were what properties? Limit changing properties. Now, limit is not my issue here. Limit is not my issue here. Limit is a very good value, 0 to 1. It's not a very dangerous value. Okay, so limit is not my issue. So that's the reason why there is no point in doing the properties also. So the only method available is what? Product rule. Let's go for the product rule. So before doing the product rule, there is a rule inside that also, a preference order. Do you remember ILATE? I stands for what? inverse, L stands for log, A stands for algebraic, T stands for trigonometric, and E stands for exponential. This is the preference order of selecting U and V of product rule. Now let me give you the product rule also. U V dx. What is the product rule? U integral of V dx minus integration of du by dx into inside integral V dx, the whole into what? Okay, this is what is UV rule. Blindly doing UV rule may not give you result, but rather preferential doing UV rule will give you a result. So according to this preference, who should be U and who should be U? V. Our function is what? 0 to 1 x. What did I say in algebra, in mathematics? Whenever you see log log, you treat it as what log? Natural log, unless and until they are mentioning the base 10. Clear? But treat it as natural log. Now, who is U? Who is V? Tell me. Log is U, okay, correct. And who is V? X. So let's rearrange that. 0 to 1 log x into x dx. And out here. Now let's apply the rule. What does the first rule part say? Log x into integration of x. What is integration of x, guys? X square by 2 minus integration of d by dx of log x. What is d by dx of log? Derivative of log x exists. What is the answer? Into what is the integration of x? We already know that as x square by 2 into what? Dx. Now, in case of product rule, I don't first of all see the limits. Limits I will apply the end. Now, what is simplification here? X square log x minus a to a sine raised to 6x plus sine raised to 7x dx. Now, minus a to a, when you see that, what should you check? Even or odd? Is it an even function or an odd function? Answer is neither. Let's see. If I replace x by minus x, sine of minus x is minus sine x. But what is the power here? 6. So sine of minus sine x to the power of 6 is what? Positive sine raised to 6x. Sine raised to 7, sine x to the power of 7. That is going to be negative. So what function if I get is, I am going to get a function known as sine raised to 6x plus minus sine raised to 7x. That is, let me give you. If my f of x is what is my f of x? Let me show you for those who are not able to think this. Sine raised to 6x plus sine raised to 7x. If I replace x by minus x, this is how it should be done. So this is minus sine of x, right? Minus sine of x to the power of 6 is what? Even power, so it is sine raised to 6 or sine x to the power of 6. What about this? Sine x to the power of negative sine x to the power of 7. So is this function and this function same? No. Is it the negative of this function? The answer is still no. So this is neither even nor odd. You are going to get stuck. In this scenario, you can actually, integration as a beautiful property. If it's plus, you can split up the integration. If it's a plus function, you can what? Split the integration. So if I visualize the integration like this, minus a to a sine raised to 6x dx plus minus a to a sin x to the power of 7 dx. Can I visualize like this? There is no rule avoiding with that. That's allowed, right? Now this alone part is what? Even or odd? This is even. What this alone part is? Odd. So the even part will become 2 times of 0 to a, and that part will be what? 0. So no need of writing that. So answer is option A. Now why this cannot be further solved? This can be actually further solved, but the answers are going to come as some sin A, sin something like that. But it will be a very tedious challenge because I cannot apply my shortcuts. What is my shortcut? Shortcut is for only from let 0 to pi by 2. A can never be converted into pi by 2. A is a random number, right? You cannot just take a random number and convert it to pi. It's just a multiple of pi by 2, then I could have converted it using some half angle or something like that. Random numbers cannot be converted. Clear? Understood the problem in this case? Do the integration 57. Minus 1 to 1, 1 by x square dx. Is it an even function or odd function? Even function. So just do it. This is a good idea of writing notes. Splitting into 4 parts. Less wastage of paper. Not working. Stop. Where is the switch? Top speed is not working. What is the answer of 57? Why does not exist? Hmm? Yes. So now, guys, we are jumping into a new topic. I wanted to know that. Okay. We are jumping into a new topic known as improper integral. So write down the topic. So write down the heading. What is that? Improper integral. Now, guys, there are two kinds of improper integral. First kind. This is what is known as improper integral of the first kind. What is happening here? Function is not the issue. Function is not the issue. Limit is the issue. Here one of the limit, upper limit is infinity. Here both the limits are infinity. Here, again, the lower limit is infinity. This is known as improper integral of the first kind. Second kind. The function may be like this. But f of x is not defined at least one point lying between what? A and B. That was a problem with your 1 by x square function. If you see that 1 by x square function, between -1 and +1, there is a value known as 0. What is 1 by x square at x equal to 0? Undefined. Na? What the issue here? So the function that you did the integration, that you tried out to do the integration, it was improper integral of what? Second kind. It was improper integral of what kind? Second kind. Okay. Now, guys, this is one type. The answer of this does not exist. Whatever you get, the answer is correct. Now, guys, sometimes what they give in the question is they will give you an improper integral. Okay, and they will ask you whether this integration answer does exist or not. That is, answer is converging or diverging. So this is what we are now going to do the test. So test on improper integral. Write down that. So understood what are the two different kinds of improper? One is limit is creating the problem. In second kind, who is the problem? Function is the problem. Just understand like that. Now, even if it's an improper integral, if it gives a value, sometimes even improper integrals also gives you a value. Do you want the example of that? Integral from 0 to infinity tan inverse x dx. Write down. Tan inverse x dx. Sorry. Tan inverse x. Sorry, my mistake. 0 to infinity 1 by 1 plus x square dx. What is the formula for 1 by 1 plus x square? Tan inverse x. What is the limit? What is tan inverse infinity, guys? So what is happening in this example? Although it's just an improper integral of the first kind, I'm still getting a finite answer. So what does that mean? This improper integral is converging. So write down. If improper integral gives a finite answer, then it is called as converging or convergent integral. It is known as what? Convergent integral. Again, if the improper integral, that the function that you did right now, that is the problem, that gate problem that we solved, was it getting a proper finite answer? No, it was giving an infinite answer, right? Or undefined answer. So that is known as diverging. So note down the point. If the improper integral is giving the values which are undefined, then it is diverging. then it is diverging. Let me give a gate question related to that. Okay, this was a gate question actually. Come later on. I'm directly giving you the related topic. Limit a tending to infinity, integral 1 to a x raised to minus 4 dx. Okay, you have to find the answer of this. This is what integral? This is an improper. A is tending towards what? So this is technically actually, if I write the integration value, this is what? 1 to infinity x raised to minus 4 dx. Now guys, the basic test of whether this is convergent divergent is just do the integration and tell whether answer is applicable or not. So what is x raised to minus 4 integration? X raised to minus 3 divided by minus 3, apply the limit from where? 1 to infinity. Minus 1 by 3 can be taken common outside. X raised to minus 3 means 1 by x cube. Minus 1 by 3. Guys, what is 1 by infinity cube? It's 1 by infinity, so 0. Minus 1 by 1. So answer is 1 by 3, right? So is it giving a finite value? Yeah, 1 by 3 is a finite value. There is no undefined values here. So this is what? Converging. And the answer is converging towards which value? 1 by 3. Converging towards which value? 1 by 3. Okay. Another gate question. The question was like this: find the value of improper integral. Find the value of improper integral. Find the value of improper integral. So since they are, and there was an option, I think so. One option was diverging, something like that. Now this integration actually we have done in the morning itself. I think so. We did with the product rule. Okay. Do you recollect that? Can I recollect that answer? What is the answer? No, that was without limits, na? Huh? 0 to same thing. Okay, 0 to 1. Okay. I forgot that. I forgot to mention there something. Okay. Okay, what was the answer after integration? It was converging, so you are lucky. No, not answer. The integration. After integration, what was the function that you got? Minus. Okay. So 0 to 1. I didn't do that problem that for finish final part. The rest I did up to this part, and the remaining I told you to just directly do it. Now, what is the challenge here? Although your answer is right, there is nothing wrong. Answer is what? Minus? Okay. Now, what is the challenge here is, when I put 1, there is no issue. What is that? 1 by 2 into log of 1 minus, that's okay. When I put 0, what is the problem? Okay, so what you made a mistake is, you took 0. What is log of 0? Minus, we had yesterday discussed this, minus infinity. You assume 0 into infinity as what? 0. Is 0 into infinity 0? No. So how actually we should overcome this? You are lucky that 0 into infinity in this particular case is 0. That was luck, not your brain that worked out. Not every time 0 into infinity is 0. So how to overcome such situations? You have to be very, very careful in such situations. Okay. So this is okay now. This value. What is this value? This is the problem. So let's neglect this. Actually, not the entire function is problem. Only this part is problem, right? So how to apply lower limit is minus limit extending to 0. What is the function? X square log x divided by 2. The second part, this part is not a problem, right? So that is 0. So I'm neglecting that. Wherever I'm getting an undefined answer, I'm going to introduce the limits there. Is that okay? Now, how to do the limits, right? So this much limits I have to separately solve. So I'm just taking the limits now. Minus 1 by 4, let's keep it there. So limit extending to 0, x square by 2. I'm just taking that function, okay? Now how to do this is, 1 by 2 I can take it outside. Now what is the benefit of this? If I put in the numerator direct substitution, so how did I told you to approach limits? First of all, directly substitute it. Log of 0 is what? Minus infinity, take it as infinity. So direct substitution gives you infinity. What is 1 by x square's value? So this is infinity by infinity. So I can do which rule? L'Hospital rule. Okay, L'Hospital rule, right? Okay, let's do the derivative of the numerator. What does the L'Hospital rule says is, whatever function is the numerator, take the derivative of it. So limit extending to 0. What is the derivative of 1 by x, log x? What is derivative of, and also do the derivative of the denominator separately. What is the derivative of denominator? 1 by x square. Minus 2 by q. Now rearrange this function. First of all, this minus 1 by 2 can be taken outside. So already 1 by 2 is there, minus 1 by 2 also coming outside. What is that? Into limit extending to 0. What will happen to the values of x? Since x is tending to 0, x is not equal to 0. So can I cancel x? So what is the remaining function now? X square, just x square. What is the limit here? So you were lucky that the answer came as 0. Understood the problem? So whenever you get an undefined value, all you have to do is just apply the limits and check whether limits gives you a defined value. If limits is giving you a defined value, you can do it. Any issues? Yeah.
But in the sum, the directly execution doesn't exist.
Where?
This sum for 1 by x squared. We saw it here. Don't we have to apply this?
Apply. You will not get an answer.
There are some.
Yeah, he asked me that in 1 by x square, why did I say it does not exist directly, right? Let me do 1 by the current when, that's why it create a problem. What are that function? Can you tell me? Minus 1 to 1. We did 2 times of 0 to, right? This question. I directly told that this is does not exist. Why did I say that? What is the integration of 1 by x square? X raised to minus 1 by minus 1. So, because 1 by x square is x raised to minus 2. Na? So x raised to minus 1 by minus 1. Limit is from. If I take minus 2 outside, I will get 1 by x. Now, 1 is not an issue. Okay, 1 is not an issue. Minus limit, what is that? X tending to 0, 1 by x. Now tell me, how will you adjust this function? If I try to do the limit extending to 0, 1 by x, is there an answer for this? Can you apply L'Hospital rule? You cannot do anything. Na? Now, when it is 1 by x, is 1 by x giving an inequality? Sin x gives you an inequality. Sin x lies between what? Minus 1 and plus 1. Cos x gives you an inequality, minus 1 and plus 1. Do algebraic function give you an inequality? Yeah, it gives an inequality, minus infinity and plus infinity. Again, those are undefined. So, can I apply sandwich theorem there? Nothing. So, there is no way of removing this. So, this is always going to diverge. So, if your limit is giving your answer, whether it is 0 or any other value, it is converging. If your limit, even after applying the limits, you are not getting an answer, then what you will do? You will say it is diverging. So, if it is diverging, that does not exist. That's the idea. But that, so there was no, because of this simple function, I thought you might understand that, because 1 by x can never be, even after applying the limits also, 1 by x can never be reduced to any certain value. Some other complex functions can be reduced, but 1 by x cannot be reduced. Are you getting my point here? Any doubts? Is it okay now? So understood what is the converging function, what is the diverging function? Okay. Next, one type of question. Which of the following, again gate question, which of the following integral, which of the following integral is unbounded? Which of the following integral is unbounded? What do you mean by unbounded? Diverging or does not exist. Options were, option A was this kind of questions are sometimes lengthy because they are not asking you to check only one function, they are asking you to check what? All the 4 functions. Okay. Now, let's start one by one. 0 to pi by 4 tan x. Actually, you don't need to do the integration. Why? What is the integration of tan x? When you come to tan and all these things, answer is what? See, how to remember this is, okay, what is the derivative of tan x? 6 square x. So 6 square x integration is tan x. That's how the logic works. Okay. So the logic of tan x is going, whenever you go for tan x and cos x, you have to go for what? Now sec x derivative is what? Sec x tan x, right? So sec x tan x integration is what? Sec x. Got the idea? So those are the cases here. Now when you go for tan x idea, you have to go for the log function. Log, tan, log, cot, sec and cot. All these functions have integration of what? Something log function. So their integration is log of tan x is log of sec x plus tan x, right now. So answer is log of sec x plus tan x. No, sorry. Log of sec x. Sorry. Integral of tan x is, right now, log of modulus sec x. Integral of cot x. That is, there are two ways of writing this. If that is the case here, this also has another formula. For those who want cos x, the answer is minus log of cos x. I always try to keep the value as positive. Now, where is sec x plus tan x coming? Integral of sec x dx is what? Sec x. Got the idea here? Now, why there is modulus sign? Whenever you are getting answer of an integration as a log function, whatever be the case, the log inside part is always a modulus sign. The reason is log x is not defined in negative values. So always the integration will have what sign? The modulus inside the log. So even 1 by x dx integration you would say it as log x. What is correctly the answer? Log of mod x. Log of what? So whenever you are getting an integration answer as log, whatever function is coming inside the log, keep it in modulus sign. So keep that in the back of your mind. You don't have to write every time, but always keep in the back of the mind. Can you do that? So we got the answer. Okay. Now, guys, why I had said that the option A did not be integrated is tan x function. Where is tan x function going to create the problems? At pi by 2, right? Now, how to check whether this is an unbounded or bounded one is just think about this. Limits, first of all, are not creating any sort of problem because the limits are not undefined values. 0 and pi by 2 are perfectly defined values. So this is not an improper integral of the first kind. Is it an improper integral of second kind? So how to check second kind? Check the inside function tan x. So tan x, is it a improper integral? Yeah, it only becomes improper when the values are pi by 2. Now tell me, is pi by 2 lying in the range? Between 0 and pi by 4, that is 0 and 45 degrees, 90 degree lying inside that. No, lying 90 degrees outside that. So with respect to this range, this is always bounded. You don't have to every time work it out, or you can work it out by doing the problem. That is, do the integration, see the answer. But don't waste time on that. We have to do this quickly, right? So option A is what? Always bounded because it is not an improper integral. Option A is not an improper integral. So it is always bounded. Now what about 1 by 1 plus x square? Tell me what is the problem here? Is this improper integral of first kind or second kind? First kind. Why? Limit is the problem here. Who is the limit? One, that infinity, upper limit. Upper limit is creating the problem here. Now, if upper limit is creating the problem, then you have to check it out. So we already did that. I think so. I gave as an example also. 0 to infinity 1 by 1 plus x square dx is what? Tan inverse x. And even after applying the infinity, we got a proper value for that. What was the value? Pi by 2. So it's still bounded. Bounded means it should have a value. It should converge at least. Okay. Next. 0 to infinity x e raised to minus x dx. Again, this is improper integral of which kind? First kind. That okay? Now, so obviously we will have to check it out. So for that you will have to, so if it's proper integral, then you don't have to check it out. Proper integral will always give you answer. So there is no point of discussing converging or diverging there. Only when you go to improper integral, then only you have to check it out. So let's integrate this. So what is that? 0 to infinity x e raised to minus x dx. Now guys, I'm going to give you a shortcut of product rule. I gave you product rule in the morning, so I'm going to give you now the shortcut. Okay, the shortcut is only applicable for certain set of functions. Not every function you can apply it. In the morning, that function was not applicable as a part of shortcut. That's why I didn't do that idea. Okay, where is it applicable? Is algebra into sine, algebra into cos, algebra into exponential. One more thing. The degree of algebraic function, whatever that is, it should be a positive integer. That is, it cannot be like x root of x or x raised to minus 1, something like that cannot be allowed. It should be either 1, 2, 3, like that values are allowed. Not even fractions of the power. That is x raised to, let's say, 5 by 3 is there. That is also not allowed. Okay, so there are some restrictions. What are the restrictions? Algebra into sine, algebra into cos, algebra into exponential, and the degree of algebraic function should be positive integer. If that is the case, now tell me guys, who is the u, who is the v? By Eilert rule, who is the u, who is the v? X is u, e raised to minus x is v. Okay. So who is the u? Keep it like that first. Whatever is a v, take the integral of that. So e raised to minus x integral is what? Why this function is operating like this? There's a famous function, there is a famous property in integration. If let's say, if assume integral of f of x dx is some function capital F of x, then integral of f of ax plus b, what is that? Same function capital F of ax plus b, but divided by what? That's the reason why integral of sine x is what? Sorry, integral of sine 2x is what? Integral of sine x is minus cos x, right? So answer will be minus cos 2x divided by 2. Got the idea? So this is the property that we are going to use here. So that's how we got the answer. And that's how you actually study in the standard formulas also. E raised to minus x integration is what? Minus e raised to 1. Because minus 1 in the denominator becomes minus in the numerator. Next thing, put a minus sign. Now don't see the original function, go the previous function. Who is the first function here again? x. Take the derivative of that. Now, who is the second function here? Whatever that function is, what will happen here? Take the integration, again integration. So, e raised to minus x into what will happen? Minus 1 into minus 1. Next, plus. This should continue on. Again, see the previous function. Don't go to the original function. Okay, we are always seeing the previous function. Who is the previous function? U? 1. What is the derivative of 1? So, logic is first function, derivative, second function, integration. Like that, go on doing. Now, once you get derivative as 0, stop there. There is no pointing further continuing because 0 into whatever value that you're getting is going to be 0. Understood? Don't worry about this problem. I will give one more example so that you can get a grip of this method. At least for now, you should stop here. Right now, let's simplify this. So, what is this function technically? Minus x e raised to minus x. This is minus. Now, limit is from where? So, where should I apply limit, guys? When I am applying the upper limit, right? For lower limit, I don't have to apply any limits. So, limit extending to infinity minus x e raised to minus x minus e raised to minus x minus, when I apply 0, what is the answer? This is 0 minus 1. E raised to 0 is 1. Now, let's solve the limit here. Guys, when I apply infinity, how to apply here? Directly applying gives me infinity multiplied by e raised to minus infinity is 0. E raised to minus infinity is 0, na? Why e raised to minus infinity is 0? 1 by e raised to infinity. That's why it is 0. 1 by e raised to infinity is 1 by infinity. 1 by infinity is what? 0. Understood, na? So that value will become 0. But the problem is, what is the situation? Infinity multiplied by 0. What did I say just before? Is infinity multiplied by 0 infinity or 0? We cannot say. We have to apply properly limits. So separately, I have to apply limits. That is L'Hospital rule here. Here I don't have to worry. Here the answer is pure 0. So that is not an issue. So who is the issue? So whatever is the issue, just take that separately. Let's keep the remaining as it is. So who is the problematic term? Just I am taking that only. X e raised to minus x. How can I write this function as? Any issue? On direct substitution, what do I get? On direct substitution, I get directly. So can I apply L'Hospital rule? So by L'Hospital rule, what is the answer? What is derivative of x? What is derivative of denominator? So this is technically 1 by infinity, na? So the answer is. So again, you are lucky. Sometimes, most of the time, what happens is the problems are designed in such a way that 0 into infinity is 0, but we are not always sure about it. We are what? Not always sure about it. So we will have to work it out. Okay. So the method to work out is always doing it properly. So now let's come back to the original function. This is 0. This is already 0. We know. Minus 0 into minus 1. 0 minus 1. So minus 1 into minus 1 is what? So the answer of this is. So we were able to prove that this is 1. So is 1 a finite number? The answer is converging. So obviously this is bounded. Even though it's an improper integral of first kind, it is still what? Bounded. So obviously option A, B, C bounded. So option D is what? Unbounded. You can go by that conclusion, but I don't prefer that. What if all the options are wrong? Let's say even though gate examination, there is a very big scrutiny and everything, but let's say if all the options are wrong, then how will you approach these questions? There are only two possibilities. Either your entire logic is wrong. That is, check your logic again, recheck your logic again. So most of the times your logic is going to be wrong. So recheck your logic. Let's say you are sure that your logic is not wrong. You are sure about your logic. then the only case is their question is wrong. So in such a case, don't attempt the question. This is not a university exam that if you are just writing the question number, if question is wrong, then you will get a mark. It doesn't work like that. Okay. The reason is, in your university examinations, you are writing the steps. You are at least writing some steps. So they give you a consideration on basis of that. Here your steps are going to be written on a piece of sheet which is going to go after your exam into dustbin. So no one is going to know that how you found the answer. So if it's a wrong question, don't attempt such questions. Forget it. There are other 64 questions available. In the entire history of GATE, around 5 to 6 times they have been wrong. This is a very rare phenomena, but if it happens, don't attempt such questions. So what is the most probable thing? Your logics may be wrong. So check it out. So to be safer, what I do is always work out option D also. So let's work out option D. What is option D? Can you tell me the integral? 0 to 1. Why this is on direct weaving? This is not an improper integral, right? But this is an improper integral. Why? Where is the function going to create a problem? When I put the value 1. When I put x equal to 1, what is the problem? Function becomes infinity. So it's an indefinite integration. Sorry, it's an improper integral of second kind. Who is a problematic term here? Function. Limit is not an issue. Is that okay? Now let's work it out. Work out the logic. Okay. So what is the integration of this, guys? Tell me. What is 1 by 1 minus x integration? Forget 1 minus x. Just think about 1 by x. What is 1 by x integration? It's a standard form of log x. What is the coefficient of x? Right? The same problem will persist here. When I put upper limit 1, is my log function 0, right? It's infinity. So I have to apply what? Limit. Limit x tending to 1, log of 1 minus x to the power divided by minus 1. Minus, when I put x is equal to 0, what is the problem? No problem. I get log of 1, which is 0. Right? When I put x is equal to 0, I get 1 minus 0 is 1. Na? What is log of 1? So that is not, lower limit is not an issue. Upper limit is an issue. Now tell me, when you see this function, even after applying limit, can you solve it? Can you solve it? Can you solve it or not? Because even L'Hospital rules cannot be applied. Why? If I directly put the values, the upper value is infinity, but what is the lower value? Minus 1, which is a constant, right? So it's not infinity by infinity or 0 by 0 form. That I'm not getting. Okay. Now in log, is there any inequality? Yeah, log inequality is a very weird thing. Log x inequality is what? Lying between 0 and, minus infinity and plus infinity. See, if you are getting an inequality or function value which is lying between some two finite values, then the sandwich theorem can be used. If your function values are between minus infinity and plus infinity, then you cannot use that. You cannot use that cases. Because your f of x and g of x, the outermost functions are undefined. Only sandwich theorem can be used if your outer functions are what? Defined. Otherwise, you cannot do it. So there is no way of, even after applying the limit, to find the value of this. It is always going to give you undefined value. So since even after applying the limit, I am not getting the answer, who is the unbounded portion? Who is the unbounded part? Option D. This function is the unbounded part. Understood how we can tackle unbounded? So understood how to tackle improper integrals? Okay. Any issue here? Yesterday itself I told you that every time I cannot do this. I told you, I will give you one more example. Product rule to do quickly. Okay, let's do this. X cube into sine 2x. Let's just one more time. Let's do that product rule as shortcut I discussed now. I'm giving one more example so that you can get a grip of the method that we are learning. Okay, what did I say regarding the method? According to Eilert rule, who is u, who is v? X cube is u, and who is v? Whatever is the first function for the first time when you write, in case of u, write as it is. So who is the function, first function u? X cube. So write as it is. Only for the first time. Second function, take the integration. What is integration of sine 2x? Minus cos 2x minus. Now go for the previous function. Who is the first function now? Now once you start, write down the first function. Now for the next functions, first function derivative, second function integration. So x cube derivative is what? 3x square. Second function's integration. This function's integration, not the original function. Minus cos 2x integration is what? Minus sine 2x divided by 2. But already there is a 2. So it will be what? Minus sine 2x divided by 4. Okay, next. Alternate plus minus. So after minus, then write plus. Again, first function. Don't go to the original function. Just always go for the previous function. X square derivative. 6x. What is the integration of this? Next, minus. What is the derivative of 6x? 6. What is the integration of cos 2x divided by 8? Now plus, what is going to happen in 6, derivative of 6? So stop there. Now all you have to do is whatever signs are there inside, simplify it out. So first function, minus x cube cos 2x divided by 2. Then here minus minus plus, so minus plus 3x square sine 2x divided by 4. Here I think so 2 can be cancelled out. 2 3s are, 2 4s are. There is no negative sign, so 3x cos 2x divided by what? 4. And finally here again minus minus so becomes positive. 6 2 2 can be cancelled, so 3 sine 2x divided by 8. And this is the answer of this integration.
Also, sign should be alternatively changed.
Yes. But here what happened was, after the second step it stopped. That's why I could not do anything further. So to show that, so alternate, this started with plus, so this will be minus. Again plus, then minus. Clear? Understood the shortcut? This actually I learned it in, not in GATE examination. I learned it in, I think so, 11th and 12th standard for entrance examination. Okay. Because this was a regularly asked question in our state syllabus. That is Kerala entrance. I went for Kerala entrance exam. So this type of questions was regularly asked. So faculty should teach this. The only restriction is this can be allowed only for certain set of functions. In x log x, I cannot do that. Why? After the second function, what happens in the derivative? If you see x log x function, what happens in that second part? X into x square by 2 you get, na? Oh, sorry, 1 by x into x square by 2. So the x cancels out. So the functions are connected. So when functions are connected, you cannot do this shortcut. Here what is happening is no function is connected with each other. X square is behaving on its own. The cos x and sin x function is behaving on its own. They are not cutting out each other, or they are not somehow related to each other. That's why we can do this step by step. Even exponential and algebraic functions are also not connected. So that's why we can do it separately. Understood the process here? Any doubts? Okay. Yeah. This was a question that we discussed right now. I told you a gate question. Same thing. Okay. Now we have to find this bit. Question number 94. The length of the curve y is equal to 2x, x raised to 3 by 2 between x is equal to 0 and x is equal to 1. Write down. Length of the curve formula is 1 plus dy by dx in the square into what? Dx. I think so. This we solved somewhere, right? Do you remember the surface generated formula that we discussed in the morning in the first section? In that volume, the gate problem was volume generated, so we didn't do that surface generated. So surface generated, first, second part is what? There are two parts now. One is f of x into what? So what they are doing there is f of x multiplied by the length. So this is what is the length of the curve. Now let's do the case here. So where I am varying from x from where I am varying 0 to 1. So the limit is from root of what is derivative of this function? 2 by 3 x raised to 3 by 2. What is the derivative of that? Root x, right? So 1 plus root x square into dx. So this is what? How did I got root x? 2 by 3 y raised to 3 by 2. Do you want the derivative idea? Our y function is 2 by 3 x raised to 3 by 2. So dy by dx will be 2 by 3 into 3 by 2 into x raised to 3 by 2 minus 1. So 3 cancel, 2 cancel. So what is that? What is x raised to 1 by 2? Now the remaining part is how will you solve this integration? What is the integration? What we have to do? 0 to 1 root of 1 plus x. How will you do that? It is 1 plus x raised to what? Right? What is the answer of this? Did I x raised to n formula, man? I'm not understanding this. Okay. And let me finish it up. I'll show you how this works out. Limit is from where? If I put upper limit, what do I get? 2 raised to 3 by 2 minus lower limit 1 raised to 3 by 2 is 1 itself. Divide by 3 by 2. Okay, now just simplify it out. 2 raised to 3 by 2, what is that? 2 root 2, right? 2 root 2 minus 1 divided by 3 by 2. Just find the value of that. What is the option given there? Let us 2 root 2 divided by 1.5. What is the answer? Just find it in your calculators. 2 root 2 divided by 1.5. What is that? 1.2 is 2 is there. Huh? Just take the nearest value. 2 root 2 divided by 1.5. 2 root 2 minus 1 divided by 1.5. Sorry, I forgot that. 2 root 2 minus 1. Where is it? I forgot that. 2 root 2 minus 1 is also there. I forgot to say that. 2 root 2 minus 1 divided by 1.5. What is the answer of that? 0. 0.276. Okay. Now, those who are confused how I got this answer or how I came to this conclusion is just see here. Our integration is root of 1 plus x. Right? Guys, listen here. How I came to the conclusion that I have to apply x raised to n. I discussed this property. Integral of f of x dx is if it is capital F of x, then integral of f of, let's say, ax plus b will be what? Capital F of ax plus b divided by a. Right? That's how you always say that sine 4x is integral is what? Minus cos 4x divided by 4. Right? The same property I'm using here. Okay, so here what I thought is this function I thought it as 1 plus x whole raised to 1 by 2. Now, how can I, this is okay, but how can I assume that this is the same thing applying here? See what is happening to x here? Inside that property, what is happening to x? Please tell me that. X is changing to ax plus b. My standard function is for x raised to n. So my x is changing to what? 1 plus x. So if your x is changing to ax plus b, this is what is referred as linear terms of linear change of x. Because I'm not changing with power. Okay, I'm not changing with the power. I'm changing, keeping the power same. All I'm doing is I'm multiplying by a on x and adding b. So here also I'm multiplying x by 1 and adding 1. So this is technically I can use the x raised to n formula here. What is x raised to n formula? X raised to n plus 1 by, so that same formula applied here. So 1 plus x whole raised to 1 by 2 plus 1. The bigger challenge is understanding that this property is applicable here. Now, where is it not applicable? Let's say if your integration is this cannot be used with this property. Why? Here x has been replaced by what? 1 plus x square. So then you have to go for the standard formula root of a square plus x square formula. right? That cannot be used. But for this you can directly use it. So what is the answer? 1.2. So understood how to tackle length of the curve. Next, this is the same problem given here. Length of the cable. There was a cable given. I think so. Some portion is missing. The parabolic cable is held between two supports at the same level. The horizontal span between the supports is L. The sag at the midspan is H. The equation of the parabola is given as y is equal to 4h x square by L square, where x is the horizontal coordinate and y is the vertical coordinate. You have to find the expression of length of the cable. You have to find the expression of what? Length of the cable. You have to use the length of the curve formula that we discussed now. The same formula you have to use it here. Okay, but let me show you the challenging part here. Okay, guys, now understand the coordinates that are given. The horizontal span between the supports is L. The sag at the midpoint is H. The equation of the parabola is x is the horizontal coordinate, y is the vertical coordinates. Okay. Now, guys, how does the parabolic cable look like? Let's say these are the two supports. The cable will look like something like this, right? If you have seen the chain that we keep in parking lots and everything in buildings, chain something look like this, right? The equation of this is what is given there. The equation, I will write it down. Just write down the question number. I will write down the equation. The equation is y is equal to 4h x square divided by L square. This equation is given in the question. You have to find the length of the cable. Now the trouble here is, this equation, if I directly use it, there's a problem. Why? See, if I directly use it from 0 to L directly, the problem here arises is, this H and L are distance. L is okay here. What is H distance? Sag from the midpoint. So this is actually equation with referring to the midpoint. So this is equation with respect to what? Y axis. So if I directly do the integration, there will be a problem. So you have to modify a bit. So how is the modification is? If total length is L, what is this length? This length is, am I right? Now, what is the length formula? Integral root of 1 plus dy by dx square into what? First of all, let's find dy by dx. What is dy by dx? 8hx Now see how I'm going to take the coordinates. If I'm assuming this coordinate as 0, this is from minus L by 2 to plus L by 2. Minus L by 2 to plus L by 2 means the total length is L. The difference between the positions is L. Got the idea? So this is how I manage this. So although you can use the formula, but I'm just changing the formula. Okay, the coordinates are taken from where? Minus L by 2 to plus L. The remaining part is okay. 1 plus, what is that? dy by dx, that is 8hx by L square, the whole square into dx. Now guys, tell me, is it an even function or odd function? Even if I replace x by minus x, I will get minus, but there's a square outside. So it will become an even function. So this can be written as 2 times of Okay, h square is what? Now you don't have to further do the integration. You just have to see which option is matching this. Let's see that. Sorry. Square, na? I forgot to do that. 64 h square x square by L raised to 4. DD, yeah. 64 h cube, yeah. This is h cube, sorry. While taking the photo, it was a bit this thing. This is h cube, so answer is option D. Understood? So previous problem itself, but I did what? Change in the way of taking the limits. Okay, that's how we adjusted. So especially for symmetrical curves, you can apply this property. But for non-symmetrical curves, you go by the standard idea. Okay, this is a parabola. It's a symmetrical curve na, with respect to y-axis. That's why I can do this idea. Understood? Now this is the volume of revolution. Don't do, you just do it at home. What is the formula for that? Pi into integral f of x the whole square into dx. The first problem that we did in the morning. Just apply that property. Next, what not 9? Question number 109. What not? So the question here is I is equals to integral of 1 by root of 2 pi. Limit is from minus infinity to infinity e raised to minus x square by 2 into dx. So I told you in integration. What is the sixth step? During the approach of integration, apply either normal distribution or Laplace transform. Now, why normal distribution is applicable here is, let me discuss the case. What is the function given here inside? E raised to minus x square. Whenever you see such function, it's mostly normal integration, normal distribution. So let's understand what is normal distribution. So normal distribution function, those who attended my probability class, you may remember it. Otherwise, if you're not forgetting it, let me recollect it. The function was 1 by root of 2 pi sigma square e raised to minus x minus mu by sigma the whole, sorry, that's 1 by 2. Minus 1 by 2 x minus mu by sigma the whole square. This is what is your normal function looks like. This is just function. I'm later on going to do the integration of this. Okay. Now before jumping into this function has a mean of what? Mu. Sigma is what? Standard deviation. Mean is what? Mu. Sigma is standard deviation. So our function, what is the mean then? If I compare it, 0 na. So I have to change this function to 0. So how to change it? There is a famous substitution for this. It goes like this. Z is what? I'm introducing a new variable known as Z. Now what will happen in terms of Z? 1 by root of 2 pi sigma square will remain as it is. It's a constant. Into what? E raised to minus Z square divided by 2. Right? The inside part will replace by Z na. But there's a square outside. So Z square divided by 2. Is this okay? So now my function is something matching the other case, right? Okay. Now from here I am going to do the integration. So what is the standard functions integration? Let me show you. Integrating from minus infinity to infinity f of z dz. Now why the answer is 1? It's a probability function. What is the total probability of a function? Probability cannot take a value greater than 1, right? It's restricted in the definition of probability. In axiomatic definition of probability, it is restricted that the maximum value of probability can attain is always what? 1. So if I take the total integration from minus infinity to plus infinity, the value is always going to be what? 1. Starting from this, we are going to evaluate this. Okay. So, what is f of z? What is f of z? 1 by 2 pi sigma inside the root into e raised to minus z square by 2 dz is 1. So if I take this outside, am I right? Is it okay? Now what is our function? What is our function? One by root of 2 pi into minus infinity to infinity e raised to minus x square by 2. Now the first thing you should decide is what is the values of each and everything. What is the value of mu? What is the value of sigma? If I compare this, don't take directly to z. Compare this and tell me what is the value of mu, what is the value of sigma. See, 1 by 2 is there, so that cannot be matched. So this is actually what mu is equal to 0. So if that is understood, then the problem becomes easy. So in the z, where is that? In this function, mu is not needed. What is needed? Sigma value. So what is the sigma value that we designed? Right? This is similar to our question. The only variation is x is there. So what is the answer of the question? Over. So this is not a regular way of doing. We already have a definition for some functions. From there, we are just comparing it out. Any doubts, guys? Next, yeah, this one, 117. Question number 117. Okay, guys, when you do this integration, let's understand the scenarios. If I apply integration here, what is the problem? Who is the troubling thing? Is it limit troubling thing or function troubling thing? Function is a problematic. Now, if function is problematic, most of the time the idea jumps out to be substitution method. But even here, substitution method is also going to fail. Why? Now, what should I substitute? Should I substitute root of a minus x or should I substitute root of x? If I, let's say if I take root of x if I take it as t, what is the differential of this? Is the replacement available? I have dx, but I don't have 1 by 2 root x. If I try to generate that, that will create its own other problems. The function will start to get far more complicated. So this indicates that your substitution method is also going to fail. Now, if function is creating a problem, in properties, although I gave you this thing, 0 to a idea, there was one property which actually changed the function. And that was this property. Do you remember this? That can be useful. Now, what is the indication that that is useful? See, there are some observations that you should recollect it. Here, a is there, and inside here there is a minus x. So that kind of an idea will help you understand this. Second thing, if the functions are sine or cos, and the limits are 0, pi by 2, pi, something like that. In that case, because of the cyclic nature of sine and cos, that is also again useful. Not only for sine and cos, any trigonometric function. Because pi, pi by 2, such limits can be operated on any trigonometric function, whether it be sine, cos, tan, cot, whatever it is. Okay. So this is the idea where I can change the function using the property. Okay, let's apply that. So let us call this as equation number 1. Okay, apply this property. So if I apply this, what will happen to my function? Wherever there is x, replaced by what? This function will be a minus x. What was the second function? The second function was a minus x. So a minus x. So if I simplify this, if I open this bracket, what will happen? A minus a cancels out, plus x. So just root x is remaining. Let us call this equation number 2. Now, what is the characteristic nature of such kind of a this is my denominator in equation 1 and equation 2 are same. My denominator in equation 1 and equation 2 are what? Same thing. The only thing is getting reversed right now. A plus b and b plus a means the same thing. Na? So the denominators are technically same. So I can directly add the functions. So let's add 1 and 2. If I add 1 and 2, what will happen? 2y is equals to, what will happen in the numerator? Root of x plus root of a minus x divided by denominator is what? Root of x plus root of. Okay, this is cancelling out. So what is this? What is the integration of dx? So answer is a. But remember, this is 2y is equal to a. So what is I? Understood this? Quite easy, na? But you should realize that this should be applied there. That's a challenge in GATE. After learning all those things, let's say after 3 to 4 months, you should be able to recollect that this is applicable. That's why the integration problems are challenging. It's not because the problem is very tough. You have to realize that this idea is useful here. Because in question, idea is never mentioned. Okay. Okay, so it's almost lunchtime. So this is integration. Okay, understood the integration time? So in the afternoon, we'll be starting with partial derivatives and multiple integrals. There are a lot of problems of that. So I'll show you different types. But the benefit is type of problems are very minimal. Same thing is getting asked and asked again and again. Okay. So the concepts are very less. The number of problems are very large. So we'll be covering that.